Hey everyone, welcome to another Tutorial Tuesday. Today I'm going to talk about a bug that I found in the Visual Studio 2019 compiler. So I switched over to Visual Studio 2019, I guess about a week ago, and upgraded my projects and just wanted to see, like, okay, do things build? You know, I was going to put it on another branch and all this other stuff just to see, like, what's going on. And so everything builds fine, but I was getting this crash. Well, not really a crash, but an error. It was failing to find certain entities. And I tracked it down to a compiler bug. It is actually a bug in the Visual Studio 2019 compiler, confirmed by Microsoft. So sadly, it's a blocking bug for me, but it is definitely an edge case. I still actually am using 2019. I've just switched over to, let's zoom in here, you can kind of see it. You can actually use the IDE and use the old version of the compiler. So I'm using the 2017 compiler and just the 2019 IDE. So that's kind of where I'm at. A little history. The way that I deal with entities and in general in my project right now is that they're all 32-bit IDs. They have 32-bit IDs. Now these IDs are generally sequential when it comes to loading from data. So it's kind of two different origins. So origin number one comes from data. Origin number two is generated at runtime. And so the difference is that these guys have the most significant bit set to 1, and these guys have the most significant bit set to 0. And so literally data as it's loading entities just, increments the ID. For these guys, I generate basically a 31-bit number and then just set it over. I mean, you can literally see it here. I just generate the number, just generate a random 32-bit ID. Entity ID here is just an unsigned int. Force the most significant bit here, and then I do a validation, basically. And then this just loops some number of times. This is not ideal, it loops 10 times. I don't think I've ever actually seen this loop even once, because this warning happens every time. So I don't think I've even ever seen this loop once, but this is just so that I don't get caught in some theoretical infinite loop. So this is pretty much what happens. It just walks through here and generates an ID for the entity. Now, this is all well and good. This should work. There should be nothing wrong with this. If I step back to, let's look. I'll just open one of these guys. So like engineering console or something. This is my data. So entities come from data, as you can kind of see here. So I don't use XML or anything like that. I use Lua tables. A lot of times they're generated, so this is data for another project that I'm working on. This is just the world file, so I use tiled to load up. If you've seen my previous videos, you've probably even seen pieces of this or other versions of this map. So each of these objects that sits here in the game, these trees, these flowers, this trigger box, and so on, these are all entities in the game, and they all generate entity IDs and so on. So that's, so these would be the comes from data type stuff. And tiled, if you've ever played around with it, or if you're just familiar with sort of tiled generator stuff, there are these palettes of things. If you look here on the left, you can see like it has a bunch of data. Anyway, this data is all generated. It generates those Lua data files. Now, these entities have to exist on Lua. And so the entity ID is the glue in a way that holds them together. So the object manager, I have two, right? One that lives in object manager. This is the Lua one. And so it has these tables of entities based on entity ID. And so they have to match, right? And that's relatively straightforward. Now, Here's the actual issue. In 5.2 and before, there is no true integer in Lua. All numbers in Lua are represented by something called a Lua number. I don't know if I can find an exact thing here. It doesn't matter. A Lua number is defined as a double, typically. You can define it as whatever you want, but it's typically defined as a double. So of course I have the concept of integers and numbers and stuff like that. Is integer, I can, somewhere down here, I can get, table values. Like if this is a table, I can get it as an integer and all this other stuff. And if I dig into these and keep kind of going through and dig deeper and deeper into this stuff, what it's eventually going to do is do this get, and there's a Lua is integer down here. So this is the sort of painful, hacky, get the integer thing that I have to do. So I have this, in 5.2, Lua to integer will return, this value if I try to convert a number that's larger than that value. So converting like this or whatever, right? So I have this sort of workaround thing that worked in this other case. It's just a pain. But either way, this worked. I can get the value and everything's okay. Except in Visual Studio 2019. In Visual Studio 2019, particularly large double values, or large negative double values in my case, will result in all Fs. And it's just a compiler bug. And it only happens in 32-bit mode. And it only happens with very large values, which of course I have all over the place because any generated entity ID is going to have that. So that's the issue. Now, of course, the really nice thing is I really wish I could update to Lua 5.3. It would probably completely solve this issue because I wouldn't have to care about this. But I can't do that because I use Dakota, and I've only been able to get Dakota to work with 5.2. I've not been able to get it to work with 5.3. Dakota is what I use for my debugger, and I don't really feel like writing my own debugger from scratch. So I'm kind of stuck here. I can't just compile in 64-bit mode because, again, Dakota, it only works in 32-bit mode debug. So I'm kind of stuck. I need to figure out what to do. For right now, I'm mostly ignoring it and just using the old compiler and hoping that Microsoft fixes this problem. To demonstrate this problem, I have created this little thing here. This is the simplest thing I can possibly think of. This is an actual value. This was the value I was testing with when I was testing this bug in my own project. So literally I just set a double to this value and then static cast it to an unsigned int. Now this is not a particularly large value. If I go here to like a programmer calculator and I say, in decimal, negative 19230533322, and you can see here in hex it should be this value. Are you actually negative? No, there we go. Yeah, that's better. In hex it should be this value. I should probably change this to a double. There we go. So this is the actual value I would expect, right? And this is not, I'm not overrunning it. This is not, it's not too big for it to handle. Shouldn't be. So that's the issue. Literally just a static cast. And so if I build and run this guy, then you can see pretty easily that it just gives me Fs, right? So that's definitely not okay. Now, if I just switch this to 64-bit mode and run this, now it's okay, right? Everything's fine. And if I did this in Visual Studio 2017, it would also be fine in either mode. It doesn't matter. So that's the issue. I've dug into this a bit. You can kind of set this breakpoint and jump in here. And if you go to debug, Windows, disassembly, you can dig into the disassembly and kind of see what's happening. We can kind of walk through this a little bit. And, so this is moving this value that I have here into this register here. And then here's our double to unsigned int. So it just calls this function. We can step into this function. Hi, we don't have this. So hopefully it will just go to disassembly. Yes, it does. And so, we can just watch this thing happen. It digs through here. It's moving all this stuff into it's moving this pointer to this thing. Anyway, I've dug through this whole thing. It's basically this if statement right here, jump it below, jumping to down here where it does this compare, and then does another jump down here, and then this guy kind of screws us over. As you can see, this seems bad. It does this like literally XOR EAX, EAX, this. So this is some failure case that it's coming through. It seems like I don't see any other way for this to kind of happen. This is kind of doing this thing with NaN, which seems bad. So whatever this failure case is causing me to basically die here. So this is never going to return the right result, right? This is just always going to fail. Because now EAX is 0, now it's all Fs, and then I return back here, and that's of course what it gave me. So it's gonna fail every time. And in 64-bit mode, this is different behavior. So if I run through here and I go back to disassembly, it's gonna look somewhat the same, but we're gonna have some different values here. Let's see, jump through here. Oh, it just did it directly. Hold on. Let me rerun this. Go back to disassembly. And yeah, so in this case, there's no branching or anything. It's just right here, this guy. And so this operand just succeeds, basically. And then here's my value, which it moves into converted value. So just EAX contains the thing that I want. That's it. So it just directly works in 64-bit mode and just even optimizes out that function entirely, even in debug mode. So that's it. That's the bug. Now I'll set a link to it. I actually filed this issue with Microsoft right here. So this is me, and I said, hey guys, this thing's happening. And so they said, hey, that's cool. We'll maybe get back to you at some point. So it looks like it has 4 upvotes now, which is pretty nice. If you guys want to do me a solid and upvote this issue, I'll put a link to it. That would be super cool. And hopefully it gets a little upvoted and they seem, maybe they'll fix it. We'll see. So anyway, that's it. I hope you enjoyed that. I hope you enjoyed this little look at an annoying Visual Studio 2019 bug. And for me, for right now at least, sadly, a blocking issue. And to be honest, even if it's not affecting you directly, it seems bad that static casting is not working the way that you would expect. Okay, that's it. So I'll see you guys next time. Thanks for watching.